Great. I like the fact that our community is changing IST as not so Indian Standard Time anymore. And I love the fact that all of us are logging in at sharp 4 o'clock, and we are heading toward change, definitely. Hello, everyone. It's great to have you all at our second chapter of Polkadot India Substrate Saturday Bootcamp. This is a highly competitive Rust and Substrate training series within the country. So you must definitely be happy to be here, and so are we, much happier than you, in fact. Now, a big welcome, in fact, to the new lot. Last week, we had a certain number of people very dedicated to the course joining in, and this week we opened up registrations again, and quite a few of you are new out here. So it's great to have you all. So why don't we just jump in? In fact, everything's going great with the course, and everyone's, I'm sure, looking forward to hearing straight from Lokesh and Tejas. So let's jump in straight to the bootcamp. Loki and Tejas, over to you, and all the best, you guys. You guys are doing great. So just keep at it. Just keep at it. That's the trick, right? Over to you, Loki.
I really hope you guys have done what was taught last week. At least had some time to go through what was done. Because I will be continuing from the last where I left off in the last session, right? So any of you, like, how do you feel so far? Is it I mean, are you still comfortable? Are you finding it challenging, or how's the energy at the moment? Josh, kaisa hai?
All right. Challenging, that is.
Yeah, initially, I believe for most of them saying that it was a bit challenging. Rust is a little bit challenging to start with, but once you're like down a week or two hard coding day and day, I think you pretty much get a hangover of hang of it. And yeah,
you do look.
yeah. So
all right.
Yeah, probably we do both. Yeah.
Those are inner thoughts.
So yeah,
all right.
That's how it is. So let's just start. So I'm going to start off with ownership and borrow model. So what I was saying is welcome back for the second session, and I hope you guys remember what was done in the first session. Just to give you a glance, in the first session we had just run over certain parts of loops. Firstly, we started off with the basic types, the scalar and the compound types. If you remember, I had started off with I32, the F values, the U values, and the use size values, right? Similarly, for all the architecture, for the own system architecture, we use use size. And then we covered compound types, those were tuples and arrays, right? And after which I ran you through on how to write a function in Rust. So using the F1 keyword, you must have already understood the main function in Rust. And then we also did in depth of what are the different iterators available in Rust, like looping mechanisms. We have loops, we have while loops, and then we have for and loops, right? So yeah, these, and also we were talking about some of the concepts of stack and heap. I didn't go through it for that in detail, but I just give you guys a brief. And for those of you who attended yesterday's Q&A, I believe we have done a comparison of str and string types. I've given a detail about a brief detail about stack and heap. And for those and also what else was covered. I had explained a bit of smart pointers, and so these were all the coding parts that we had done. We had also covered the basics of Rust and things like that, right? So if you guys, just by looking at this, you able to remember and everything is good, we shall just start off with today's topic. So today, what I want to first start off with, so I've always explained Rust is fast and Rust is a systems level program language, and it has a model called ownership, ownership and borrow, right? So yeah, so what do we do I mean, this is the main distinguishable feature of Rust when compared to other languages, right? So let's just directly start off with a brief of this. So to start off, I want to redefine the concepts from last time, a little bit of why ownership and borrow model is good for us, right? So there are different models of how different programming languages have their memory management. So one, like for example, Python or Java has something called as garbage collection. Even Go has something called as garbage collection. I mean, it's called a garbage collector. And in languages like C++, we do manual memory management, and what Rust has is basically ownership model, right? So each of these three different mechanisms has its own pros and cons. To begin with, see, if you see garbage collection, what it is it is you I mean, developers who are writing code on programs like Python or Java, you can't make mistakes, right? When you make like write code on Python, because you don't know like what's happening when you say let x is equal to 1, let x is equal to 2. It's all handled for you. The garbage collector takes the value that you just assign, I mean, or instantiate in Python, and it handles the memory for you. You're not doing it right manually. So that way it is like less error prone. And second, it's fast to write. It's like you just don't need to get into the inside details of how the language works to write your code. All you need, you want to write a small factorial program, you can quickly just define the first thing you want to do it via recursion. You can quickly write it. It's possibly like around 3 lines of code and you're done, right? This is the pros of garbage collection. But what are the I mean, disadvantages? You literally have no control over memory. Like for applications that are very require you to have memory safety and is very I mean, requires you to have a very fast performance at runtime. That cannot be done at a garbage collection with a garbage collector, because garbage collector is another layer and it occupies memory, and processing stuff on the garbage collection by the garbage collector takes time, right? So once you instantiate a variable, the garbage collector needs to identify that, allocate memory to it, and whenever you're just closing your function, it needs to learn to drop that variable from memory, free that memory space, and so that the other function can run. So these are the things, right? So that these are the cons of garbage collectors. And when you come to manual memory management, what happens is you have in-depth control of every variable, like precise control over the memory, right? It has a faster programmed runtime and also a smaller program size, because there is no such thing as a garbage collector occupying more space in your code, right? But one of the cons, the major cons in any of ownership or manual memory management, is that it's error prone. As developers, you need to know when to allocate and deallocate memory, like I mentioned earlier. And slower write time. What is slower write time is basically that the compilation of a program takes longer when you're in manual memory management thing, because first it needs to compile the entire code, understand, give it memory at stack as a defined memory, and then it would give you a binary or executable, right? But now what is different about ownership model? So ownership model, like I said, Rust is memory safe. It has the same control over memory, but the error part in manual memory management, that every developer needs to, like, I mean, just an example, right? You need to allocate, deallocate memory, and if you try to mutate immutable value, immutable string or a character or any variable, it will throw you seg fault errors, right? So that all is gone in Rust, because thanks to the ownership model, because the ownership handles the allocation and deallocation by a concept of traits. It has a drop trait and a deref trait, and also a ref trait, which will handle all of these things in the, like, I mean, while the Rust is the basically the borrow checker and the will handle all this for you, and it won't let you even write code that has errors, right? So that is the major advantage in Rust, and it is fast. There is in Rust, there is no garbage collector at all. So the program size is small, and Rust is just known to be very fast because everything is defined, it knows everything, and stack memory is always loaded with the code. Only enough size for the memory, like the application to run, right? The downside to any of these manual memory management languages is that you need time to compile the code, and also for developers to pick up such a concept, it takes a little bit of learning curve. But like I said, I'll insist again, it's not that hard of a curve. It's pretty simple once you start writing a code daily on it, right? So these are the pros and cons. Now as we move on, right, so what I want to say about when I said ownership model, right, I want to give you like some of the examples that we have for the ownership model. So in Rust, whenever we say I declare a thing, so let s is equal to hello, right? So what happens is that so now this I have declared a variable let s, and this s is basically will live only until my line number 3, until my bracket closes, right? The scope of this s is within the main function. It doesn't go beyond that, right? Similarly, if I try to write another variable inside another closure or another function with the bracket syntax, now say let s1 is equal to by, right? So what happens is this variable has a scope only. Can anybody answer this? So what is the scope of this variable? Where will the scope of this variable end? You guys can just
within the parameters. Within the parameters only.
can you tell me the line numbers?
3 to 6.
Exactly. So yeah, that is exactly what it is. So this variable will only live up to line number 6. If I try accessing this variable outside line number 6, you're going to get an error saying this no longer has scope, right?
Is this syntactically correct?
Yes, it is syntactically.
Like in the other languages, we have to define functions and something before the brackets, right?
So this is just a function, this one, right? It's a syntax. A parenthesis means it is a code within a code. So in Rust, you also have a concept of closures. Closures are basically your anonymous functions in JavaScript or Lambda functions in Python. So yeah, that is what it is. I'll show you more of closures throughout the code, but you can do this. It's fine. So if you see, this is the error that I'm getting. So if I were to print s1 here right after line number 7, it says a loop help exists with s, but it's not able to find s1 in this current scope, which means s1 scope ended here, right? So this is how ownership works. So so basically, if you see the memory points, what will happen is there's a variable s1 declared at line number 4 at stack. Okay, it live at stack. It's a string literal. So you guys need to understand. For those, so this is strictly for those of you who attended yesterday's Q&A session. I want you guys to answer this before I give the answer to other guys. Other guys, feel free. It's fine. Nothing is going to happen even if you don't know this concept, because I will explain it. So for those of you, so I want you guys to tell me where. So what is the difference between line 4 and 5, and where do you think in memory will these two be stored? Yeah. So you can either text or please come out. You can just open your audio, not required for video, and answer this.
I think line 4 is string literal, while line 5 is string object, and I think line 4 is stored on the stack, while line 5 will be stored on the heap.
Exactly. So I'm sorry, I didn't catch who you were answering. So I'm sorry, I'm not able to see, but whoever it was, good job. That is the correct answer. So so this is exactly it. So the difference between line 4 is this is string literal in Rust, and S1 is basically a string type. String is more of a data structure, and also for the please when you're answering, please give out your name so that I know who you are. Could you also explain to us what is the difference between a string type and an str? At least one difference that you can point out. Anybody?
Yes, one difference is that it's Jibril Gupta,
Okay,
is
got it.
talking.
Nice and
Yeah,
visible.
string literal is immutable, while string type is mutable.
Yeah, exactly. Spot on. Yes. So the string type is mutable and string literals are immutable. You can never change and they're stored in stack. So those stuff that are immutable are only those data that are stored on the stack. And the other difference I want to point out is string type is of dynamic memory, which means it can change. That is the entire concept of mutability, right? And this is not dynamic. So yeah, so this is a brief example of how ownership is. So I have prepared a small okay, this is happening again from the last session. Are you guys actually seeing the window floating on my screen?
This time you didn't even use the float variable.
Yeah. So I don't know how this is happening. I'm using Manjaro Linux. If somebody finds this out, let us know what's wrong. So yeah. So yeah. So it's here. So just to explain this small piece of concept, so here I have written a small function. You have function A, so I'm using the F1 keyword, which I have declared variable X and variable Y, and in function A, I'm calling function B at line number 5, right? I hope the screen is visible enough for you guys.
Yeah, it's visible.
Have a function B, which I have just defined a string type, right? One is a string literal, one is an type primitive type of an integer I32, and the next one is a string type. I mean, basically the string dynamic type, right? So, and if you see in function A, I'm calling function B, and so when the moment the compiler understands this code, so what exactly happens in the background? So you have stack a memory like this, right? Stack is a rectangle reason because this is a fixed memory. The size here in stack is always fixed, right? Pre-compile time or at compile time or pre-runtime, right? So here, the moment I define A, let X and Y. So function A, X and Y are two primitive types, a string literal and an integer type, which is of fixed size and it is not immutable. I mean, it is not mutable, right? So it's defined at the stack for, so there's a pointer for A and it has X and Y. And then at B returns a value like X. X is of type string type, right? B holds X here, right? But here X and Y are the actual variables, X and Y, the str and I32 values. But here, this X here is a reference to a pointer in the heap. So if you see, I have defined X as world. So this world is not stored here. It's stored here in my heap because it's a dynamic memory. So it's stored here and a reference. So X will point to a reference in the heap. So the address location where world is on the heap, that is what X will have. And that is what the stack will be defined at compile time. And the advantages of heap is that it can increase, I mean, it can grow in size and reduce in size as runtime requires, like whatever requirements, right?
Oh,
So
okay. So location. Okay. So basically, the details of the data type are stored on hack, while the actual data is stored on heap.
yes,
So
that is for those are for the dynamic types, right? And something to note is always pushing to stack any variable to the stack or reading from a stack is a very fast operation. It's very fast, very quick, because the compiler already knows where all these are, right? But whenever operations on the heap are going to be expensive because the compiler needs to first understand the address. It'll just allocate an address, and then this address will be re-referenced to this a stack pointer from which the stack will try to read, right? So those are the advantages. So this small image, I'll leave it in chat. Like, I think pages, you can just share it with them. I've shared it with you guys. So just for explanation sorts. So yeah, that is about this, right? And moving on, I just want to quickly run through some of the. There are 3 rules for references and ownership in Rust. So these are something as a coder you need to know. I'm just directly going to take you guys through the rules, right? For an ownership, there are first and foremost Yeah, these are the main things that you need to follow. Understand that each value in Rust has its own owner, right? And that there can't be multiple owners for a single value, right? And when the owner goes out of the scope, the value will be dropped. So that is what I showed you by line number 5 here.
So
right?
so what do you mean by owner size? Can I have
So
some
owner means so owner here. So who's the owner of S in line number 2? I mean, hello in line number 2. S is the owner, right? So owner is the first time when this value was instantiated.
Right.
Yeah, the variable was declared. And I want all of you to come back to this exact book, understand ownership rules. These are the 3 main rules. Whenever you're coding, remember this. You cannot try to play with a variable at the same time. You can't change the value of a variable at the same time, right? So that is about ownership. And similarly about references and borrowing. So like I said, I mean, guys who had attended the session yesterday, there is I had also explained the concept of ampersand and the deref rate, right? Can any of you just it's all right, whatever it is, me and Tejas are here to help you out. Can you just give a brief explanation of what does the and symbol, ampersand symbol mean, and the asterisk symbol we'll leave it out for later.
And helps to store the address of where the pointer address, and the asterisk helps to restore that address and the value in it. Restore the value in that address.
Exactly. So so let me just declare, so now say let x is a vector of 1 2 3 4, and I'm sorry I didn't catch your name again, but that is the correct answer. Yeah. For I
Yes,
in
yes.
x, sorry.
Yes, sir.
Yes. Okay. Yeah. Yes. Thank you. Yes. So for I in letter, and if I try to copy, like say if I is equal to 1, right? I want you guys to print basically S, right? So yeah, if I were to write such a statement, the compiler is going to tell me that there's an error here, right? Just taking some time. So if you see, okay, let me just cover this. So yeah, if you see the first at line number 12 itself, it's so what happens in a for loop, it just gives you every single variable of that basically of the value, right? But if if the first iteration is equal to 1, I should be able to compare 1 to 1, right? It makes sense, complete sense for me to do that, right? But what is the error here? It has no implementation for and integer is equal to integer. 1 is an integer here, but I is not of type integer here at the moment. It is of type and integer, which means it holds a reference to I. So and if you want to see that what is the address there, so you can do this and print I. So if you see this, okay, it's not printing this at the moment, but yeah, let's anyway keep it for this. So basically what it happens, so I will have something, an address basically stored onto it, and the address is a hash, so it will be something like 0x7EF98, whatever, right? So this is an address location. This is what I holds, the and integer. So you're trying to compare this address with 1. Your compiler won't let you do. So this is the concept of reference or borrowing, right? You're holding a reference to the original value, right? To fix this error, I need to dereference the value. So if there is an and, so basically it holds the address. I want to dereference the address. So what does dereference do? There's a trait also called dereference. It it gives you the original value at that particular address, right? So if I were to do this, yeah, so you see right now that error is gone, all warnings are gone, and I'm able to print the value of okay, yes, here. And if you see the value 1, right now it's able to compare, there are no complaints. And if you see the address of 1, this is the address location at which this 1 will be stored, right? Is this clear for you guys? How references and borrowing happen? Okay, you guys just can say yes or whatever.
So colon P means it's extracting the
Pointer.
pointer from that variable.
So yeah, and quickly I want to show you a little bit of borrowing as well, like how variables. So let me just keep this variable. I'll just comment this code for now, and let's deal with only this. So right, or let us not do this also. Let x is equal to string. So yeah, and so right now what I'm going to show you is now say I have defined a variable x which is of type string, right? And now I say I want to move this x value to a variable y which is equal to x, right? I've done this. Now let us see what is stored at these locations. I mean, what is stored at x and y. Right, so if you see the variable right now, so you see it's not even able to print what y holds, right? It's throwing me an error. It says move occurs because x has a type string which does not implement the copy trait, and the value moved here, I mean the value is moved to y in line number 3, y is equal to x, right? So the error basically here is value borrowed here after move. So Rust does not let you do this. If you were trying to do it in any other language, it should have been like simple, and you guys wouldn't understand what this error is right now, right? So this is the concept of borrowing Rust. So what happens is here string is a data, when like I said, it is a type. However, it's more of a compound type basically, where you can store it at heap memory, right? So what happens here is by default there's a variable x that you've assigned, right? And the moment I assign in line number 3 that y is equal to x, this x variable is gone. It's no longer there. The x variable is gone. It's no longer there, and it directly is moved to y here, right? So what happens here is that now the owner of this is y, and then I try to print x. It's saying I don't have x, so where will I print it, right? So that is what is exactly what the compiler is telling when it says value is borrowed here after a move. It is moved to y, and after that you're trying to access a variable that is no longer there, right? So how do we fix such an issue, right? There is something called as dot clone that you can do. Okay, before I even come to clone, I want to show you this piece of code work for say primitive types. So now say let x is 1, and now say let y equal to x, and now I want to print x or y, right? So before I print these two, I want somebody to explain what am I doing when I'm redeclaring 2 and 3 and x and y, and I'm redeclaring x and y here, right? I had explained this. There's a name for this that I had given in the last session. If somebody remembers, please feel free to just answer, right? Anybody, you can just come on. You can just say it out. It's fine.
We have some
Or
answers
is it
from
in chat?
Luki.
Okay.
I think shadowing.
Yeah. Okay. Everybody answer on shadowing. Yeah. Cool. That's the right term. So yeah, that's what I'm doing here. And if you see the error that I was getting when I was trying to do the same operation with a compound type or a custom type, it is no longer there. The compiler is not throwing me. It says so x is 1 and y is also 1. That error where the value is moved, borrowed here after a move is not there, right? Why does this happen? Because there's something called as a copy trait. So copy is a trait that Rust has in its standard library. Basically what happens is whenever a primitive type is moved to another value or anything, by default x, there is a copy of this x moved to y. It's not a deep copy, or it's I mean, it's basically a shallow copy where of another memory will be allocated for y with this variable, and this only happens with primitive types, right? So the case with your own types or your custom compound types, right? So which is why the compiler was throwing an error, right? And to fix that, we have something called as the clone. You can do clone method, and when I apply clone for any of my compound types or something, now it will be fine, and it's going to print, see, x value, right? Is no longer complaining. And if I even try to print y value, if my y value will also happen. So clone, what clone does is it does a deep copy of the original value. So this is a little bit of intro of references and borrowing, which you will need to use in everyday code. And again, there are rules to references, right? Let us quickly run through. So like I mentioned, the memory diagram in stack and heap, I've very simplified it for you guys in the other diagram, which you guys might get it in chat. And yeah, so that is what it is. But I want you guys to come back to this book and then come to the bottom of references sections and borrowing. And these are the two main rules about references. At any given time, you can either have only one mutable reference or any number of immutable references, right? And references must always be valid. Got it? So so this part, I shall cover it quickly now, maybe. So let's do this now. So if I have x as 1, and so this part you guys have understood, so I'm just going to comment this entire code. So let us keep with this, and now say I hold a reference, right? I hold the and reference to y. Now y is an and reference, and say I have the same thing where I have letter z is also holding an and reference. And now if I want to print any of these values, right? Say I want to print z here, the compiler is fine, because I have basically y and z here are just references to the original value. So it is able to get the reference and give you the value, right? So this is fine. But if I were to instantiate another variable, say a, and I want to change the original value, like mutable reference of this, right? This the compiler won't let you. So that is the first rule. Basically, if you see, it says help. If this is intentional, I mean, sorry, the error is here. Cannot borrow x as mutable as it's not declared as mutable, right? Okay, that is the first error. Let's make it mutable. So yeah, so we have declared it mutable, but it now the compiler is saying cannot borrow x as mutable because it is also borrowed as an immutable value. Because in line number 8 and 9, I have referenced my x value as an immutable value. I'm not taking it as a mutable value. So the compiler won't let you do this. So this is how Rust prevents segfault errors when compared to C++, right? Segfault errors are basically when you're trying to mutate the same variable at multiple instances, right? Which will lead to data races. Data races lead to segfaults, right? Rust prevents data races and segfaults by doing this. So this is exactly what I had explained in the differences slide, and this is how Rust prevents you. So it doesn't let you do this operation at all. And like I said, the scope of x, y, and z will end once it's used, right? So now if I were to do something like this, now if I consume both my y and z, right? Now my compiler will be like, okay, chalo, I no longer have y and z at okay, wait, is also borrowed as immutable. Okay, yeah, I'm sorry. So the concept is you can never have two immutable points that are moved, and then you cannot have another mutable reference to it, right? That is not allowed in Rust at all. So that is the concept of the first rule, where basically what I was saying is at any given time you can either have one mutable reference or any number of immutable reference, but you cannot have multiple mutable references. So multiple mutable references would look like so this part you guys have cleared. So now say let b is equal to and mut x. Now this will not have, because so yeah, so it says first mutable borrow occurs here, second mutable borrow occurs here, right? And first borrow is later used here. So Rust is not going to let you do that, because cannot borrow x as mutable more than once at a time. right? This is exactly what it is saying. You can only have one mutable reference at a time, right? And let's just try something that I wanted to do. Say if I
So having multiple mutable references is actually valid code in other programming languages,
no,
but in Rust, it's like it doesn't make sense to have two sources of changing the original value. So that leads to a lot of undefined behaviors and data races.
exactly. Thanks, Hey. That's exactly the first rule. And also, right now, see, I'm having two mutable references. Previously, when this line was uh, below at line number 13 below B, it threw an error saying you can't have two mutable references, right? Which would read to data races, right? That exactly what they just answered. And but if you see, if I delete this line and move it up above B line, now my compiler is happy. So the reason why this phenomenon is happening is because had a mutable reference. I used up A by printing it out or doing some operation, and it's no longer there. It's that reference, that mutable reference is gone, and now I have reassigned B as another mutable reference, and my compiler is able to print the value, right? So this is what ownership, borrow, and references are. These are the rules of references. And another small thing, probably yesterday someone had a question, is into slice types. Slice types are basically, now say I have defined a variable string, right? So I have defined this, and now say I want to say let y is equal to an and reference of x from say 1 to the rest, right? Now can anybody though okay, those of you were yesterday can answer it easily, but it's an open question to everybody. Can answer what the output of y would look like? Yeah, you can just leave a message in the chat. I'll just check. Yeah, exactly. So yeah, so these are string slices. So I hope everybody has understood what a slice type is. Basically, this is the output, and all of you guys, congrats. So yeah, this
Lokesh, may I interrupt?
Yeah, sorry.
May I interrupt? So
Yeah.
can you remove the reference? Can you remove the ampersand from X?
Okay. So yeah, you see,
Okay.
this is the error. It says the size for a variable at string as str cannot be known at compilation, because slice are string types, like str types, right? It has to know what is the size, and to know the size, it needs to reference the original value to know what is the original size of. So thank you, Tejas, for asking that. That's a good question. But does everybody understand the error and how it's fixed? I had also shared a video about stack and heap for those who wanted to, want to go through, understand it in detail. Yesterday, I'll just leave the same link here. So yeah, so with this, I have completed the first part of today's session, so which is ownership and borrow. And yeah, we can take 2 or 3 minutes quick break just to either answer questions, or you guys want to get some water. Yeah. Please come on audio and just explain it. I'm not able to figure out if you guys are responding, or Harsha, is it all right to open the audio? Or okay.
Yes, we're just doing that. Yeah, can you try that now? You guys can unmute yourself.
Hey, Lokesh. Like, I'm not getting what's the use of double dots over there in the line 4. Why do we have it over there?
Okay, so this is basically what happens is, so index number 1. So here, any string type or string literal will start off with index 0. So B is at 0, Y is at 1, and E is at 2, right? So here, when I say, this syntax where you basically define an array, right? And this 1 refers to the index number of the value. And when I do double dots here, it just means that it will give you the value until the very end of that string basically here. Or if I just say, if I make it just 0 to 1, now the output will change for me. Reason being, so you see from 0 to 1, it gives the first index b, but it doesn't give y, because in this range syntax, like I explained in a for loop session in the last, in the previous session, right? They just,
Yeah.
I had done this, right? Yeah. So what will happen? This is not inclusive of the final value, so that is why only one number is coming. So yeah, clear.
And why do we have this like pointer, like end symbol over there in front of x? Because it's referencing over there to that address.
No, that is because, so if I try to access the variable x and try to get the values for that, the compiler doesn't know exactly what is the value of x, because string is of type is dynamic nature. It can either grow or reduce, and it doesn't know what's the actual value of x, right? So which is why you will get an error like this: the size of values of type str cannot be known at compilation time. So which is why when I give you a reference to this address, so it will read from the address first. So the address by default will say, for a string type, I think it gives you about 4 bytes of data or so, and out of that 4 bytes of data, how many bytes are actually stored, right? So it will try to read from that, and now you can read from this syntax of that value in that address location, what is it that you want. Because so basically, like in stack, if it's a 4 bytes that would have been assigned, so just imagine it to be a rectangle with 4 different slots in it, right? That's how it is.
But how does
Okay,
the contain
got
the
it, Mike.
size?
Okay, yeah, someone else also had a question
But
here.
how does the address contain the size of the string? I don't understand.
So yeah, so by default in Rust, okay, let me do one thing. I'll just show it directly with an example, right? Now see, I have defined a vector here, right? So vector has 2 functions that you can call. Vector has vector.length, it has capacity, and it is mutable, right? Vector is another compound kind of data structure in Rust, like a hash map. It's basically an array. So there is a difference between an array and vector in Rust. Array is of fixed size and its length is known. Vector is of dynamic size. It can grow or reduce, right? So that's a brief of it. So let's just say I print x dot length first and x dot capacity, right? So and one more thing. So yeah, I want to, right? So if you see here, so let us drop this syntax and let us do like so yeah, so I have created x as a new mutable vector data structure. I have pushed one value to it, right? So now if I just print the vector x here, so you see, like I explained, so vector is another data structure that Rust provides, which is dynamic, and it will be stored in the heap, similarly of how string works. So I just wanted to show vec as a different example so that I can cover the data structure, the data type structures also provided. So if you see it, I have pushed only one variable, one, right, one to the vector, but you see capacity is throwing us 4, whoever it was. I didn't get your name, but yeah.
By default, the capacity is given. No? It is an array only. This is some
Correct.
concept in C++. Yeah.
Yeah, so so by default, at least 4 slots are given to this vector, because the compiler doesn't know what will be the size of x at compile time. Only at runtime it will know its value, right? So by default, it's a minimum of 4 bytes is assigned to this variable, and it can grow in length. So like I said, right, it is stored on heap. You can have n number of n number of len size, right? So, but yeah, does this answer your question? It was a very good question, and thanks for asking. And I believe for all of you here, asking questions, even be it very primitive, very simple, you see, at least we could get through this in detail, right? So as when I'm teaching also, I kind of forget, like, okay, like, should I be covering this, should I not, or those kind of things. So when you guys ask questions, I'll be like, okay, yeah, let's do this anyways. So yeah.
So what you're suggesting from here is the address contains other size, like there is some.
For all dynamic types, there is a default size that is assigned in the heap memory, right? That's how even smart pointers work.
Okay.
Yeah.
And,
How
like, I don't understand why there is so many question mark, exclamatory mark, star, and ampersand. Maybe we have ampersand mute. Like in other languages, it is kept very simple. But why is
So
it?
this concept, I explained it in the last session. So mute is a keyword that basically lets you declare the variable as a mutable value. By default, when I say x is equal to vacuum, it's an immutable variable. It's an
So it will
immutable
constant.
variable. But if I want to push some values to x here, I need to explicitly declare it to be mutable.
So without mute, it is always constant.
It's not a constant, it's basically immutable. So all constants are, so there is a concept of constants and variables. Have you attended the previous session? Like
I missed some of the part because like I was hearing, but
okay, okay,
yeah.
cool. So yeah, I have explained constants and variables. There are differences in constant variables. Const are by default, you have to annotate the type, and it is also immutable, right? And it has of global scope. But variables, on the other hand, it is of only main scope, and basically wherever function scope it is actually. And by default, whenever you declare a variable, it is immutable by default. If you want to change the value, you have to declare the mute keyword, right? And the question might arise, why do we have this thing? It is a memory safe operation. You're not trying to play around with Rust at all. Rust is very serious for you. If you've designed declared a variable just as non-immutable, it is just a variable to just live within the function scope. So that is where you would use a variable which is not which is immutable at a function level. Consts have a global scope. These are the use cases, right? So this is how you can keep, so these variables will only live within the function and it's out of the memory. So it'll be smaller program size, faster execution time, and yeah, all those things. Is that more clear now?
Yeah, got it.
Cool.
So let is like a loose variable. It can be or it cannot be mutable.
Yes.
Const is like, it has to be immutable. So you can't do anything with that. That's the main difference.
Lokesh, if I want to assign another value to A in between 12 and 13 lines, how to do that? Line number 12 and 13.
Okay, here, what do you want to do?
Assign different value for A.
Here. Okay, so you're
yeah.
saying that let x, what is x? Let x be there, and then I have defined A, and you want to assign another variable. A is of type something, right?
Different, maybe 2, A equal to 2 or something.
Okay, A equals 2. So let's see what happens. So first and foremost, this is a first error that you should be telling me, but it's fine. So yeah, see, expected due to this value first of all. So if I want to change the value, so like I had explained yesterday, A is only holds a reference, right? I cannot try to this one. So if I want to do that, I need to dereference it and then do that.
So
yeah.
This is the only way. There is no other way, right?
Yeah, you can still do that because you have a mutable reference, right? You can still assign values to A. Nothing will happen to it. But the only difference is that first of all, you need to dereference the value A and then assign any operation to it. Yeah, and also remember the rule: you cannot have multiple mutable references. You can only have one mutable reference at a given scope.
Okay, but after at line number 16, we can do that, right? Basically, at line number 15, A was used. So at line number 16, we can use.
No, yeah, you need to declare A again. Let A is equal to something.
No. I'm talking about X, mutable X.
Yeah, you can. Yes, X will work. Cool.
Thank you.
Yeah, sure. So with this, we'll just start off with the next section that I want to take. So I'm just deleting all of this code, and all of this code that I have shown is
that ampersand, while you were slicing the string, So the ampersand
Yeah.
holds the type and the address in the heap. Does it also stores the size?
No. Yeah, so it will basically, the ampersand will hold the address location along with the size. It will have a default size, like I showed it to you, right? Yeah, in this example, I had showed it in the vector example, capacity example. So there will be a default size similar to how string is. There will be a default size assigned to that reference, because it can grow or reduce, right? So if you see, it has only one value, 1, but it has a size of 4 bytes, because we know vector is dynamic and the compiler doesn't know at compile time. It only knows at runtime it can either increase or reduce, right? So it will hold both the data.
Okay, I was talking about the previous example.
So this is also the same, because string
Same.
is of dynamic size. The variable hereby can either be longer or shorter. So the case would change if it was string literals. So like I said, in types of primitives and string literals, what happens is you have a fixed size, right? This is fixed at compile time itself. It is no, this is stored in the stack, like how Jibril had answered, right? So this is stored in the stack. So at stack, every memory in stack knows its address and knows the size of the value also. Both will be there.
Okay, thanks. Yeah.
So yeah.
Lokesh, I also have one question. This is Rehan, by the way.
Yeah.
See, we are storing, when we are using compound types and we are assigning it to another variable, it is borrowing is occurring, right? The idea being that it is stored in the heap.
Yeah.
My doubt is that, let's say we somehow initialized a struct which only has primitive types. So in
Correct.
sense, we do know the size that the struct is going to take, but the borrowing still occurs. So
exactly. So the answer is in your question itself. The next topic that I'm going to quickly cover is structs and enums. But yeah, I'm glad you got the question. So struct. So can you tell us what is a struct first? Because the next session is, the topic is about struct. And
struct holds variables of, well, it could be primitive and compound.
Yeah, but what is a struct? What is a struct? Struct will have attributes that can be primitives, right?
Yeah, attributes.
Yeah. So what is a struct to begin with first?
A struct is a non-primitive data type. Like, to define non-primitive data type, we use struct. Like, if we have to make our own data type, like if we have to
so I had mentioned a name for such data types.
Compound.
Yes. So struct is again similar to tuples. Basically, it is a compound data type which is compromises primitive types. So even a tuple does the same thing, right? Tuple is, you can have a string and a number, or like two different primitives stored inside a tuple, right? Struct is basically to begin with a custom type, or a structure which comprises of attributes. These attributes are of primitive types.
Okay.
So to begin with, structs and enums are the building. So Ajay, I will answer that question by showing you via the code. But the answer is basically it's a compound type, right? Yeah, so that is the answer, but I will show it to you via code. So structs and enums are the basic building blocks of Rust. Because everything that you do in Rust, you will need to define a struct. You will be using a lot of enums to basically differentiate different custom types, right? So a brief of struct, like I said, is a custom kind of. It's not a compound type, to be honest, but it's similar to that, where you can hold attributes of primitive types. And enums, what are enums? Enums are basically a custom type. Enums are actually a type. You create a custom type for yourself to hold a different a family of different members in enum, which differentiates each one of them. For example, if there's an enum called color, so I declare a custom enum called en color, and I have different colors, right? You have red, so we just stick with RGB for now. So green and blue. So these are the three different variants in my enum. right? So this is a custom type, and if I were to use this enum type anywhere, I would so what I would basically do is that I will say color red, right? So this is how I'll access every single member of my enum. Okay, so enum is a custom type on its own. Now this is a brief of what struct and enums are. So right, to begin with basic structs, right? How do you define a struct? You define the struct with a struct keyword and enum with the enum keyword, right? By default, anywhere you see an enum, it's of a custom type. So struct, and say now I'm trying to define a user struct. So now I say struct user, and my user. So how many of you here understand object-oriented programming? OOPS concepts, at least to a decent level, right? So yeah, so what happens in an object-oriented program? You create an instance. For example, an animal, you create an animal class, and you add, and that animal class has attributes or properties to it, right? Similarly, so in Rust we do not have OOPS methodology or the concept at all, but what we have in turn is structs, and I mean, I wouldn't say it's very similar, but you can at least reference the concepts like that, right? So struct, here I defined a user as struct, and say now I want to define certain attributes to my user, right? So say we are defining some kind of service, a Twitter or a social network, right? So we can have an active symbol, active, which comprises of a type bool. So this is how I define a struct initially when I start off my code, right? So active, and then say username, username of say of type string, and then you can have email, and then you have yeah, so that's pretty much it, right? So these are user struct, and these are the attributes of my user. A user can be active, will have a username, will have an email, right? And these attributes are of primitive types, right? So this is an instance. So every time I want to create a new user, so what I will do is let x is equal to user, and I want to define each and every guy, right? So active, active is false, username is a string, which is say Alice dot toString, so that I have the string type here, and email is similarly alice@gmail.com. Right? So this is how I define a like instantiate my user struct. So this is where you define the user struct basically, and its attributes and the primitive types, and this is how you will be defining the variable. And now if I want to print it, user is of type user, right? So now if I try to print it, you will get this variable, but you can see it says you cannot, the first and foremost error here is you cannot format it by using this syntax. This is called the formatting syntax, right? And it's telling us that add the debug trait. So debug is basically, so like I said, primitive types can be printed, or you can do whatever it with it. These are all custom types. Your enum, your structs are all custom types or custom structures that you're using, right? And these needs to be implementing all the trait. And like I said, in Rust we have two different types of macros. One are regular macros, which are defined by the exclamation keyword, and the other type of macros are attribute macros. Attribute macros are syntaxed with the hash symbol, and then you add derive, right? And derive basically does is you have different traits, like I said, the deref trait, the copy trait, the clone trait, the add trait, the sub trait, there's so many, right? So like that, one of the traits is debug. Debug lets you print stuff. So the moment I say debug, so I say on top, above, right above my struct, right? That is right above line number 12. When I define the attribute macro derive, what it does is derive implements this particular trait for this particular struct. Got it? So like this is how this is what it means. Basically it implements the debug tag for user, and now when I try to run this code, it should be fine. So yeah, if you see, I got the user got printed like this. And also I want to show whoever asked that why are there so many symbols and stuff using. So this is a regular formatter, just a colon question mark. If I want to pretty format, you can use the colon hash question mark to pretty format. What is the concept difference between pretty format and regular format? Is just that pretty format, your code is formatted like this, and you saw the other format was just a straight line, right? So this is how you basically define structs and stuff, right? And structs also, like for example, when you have defined in oops concepts, when you define an animal class, an animal will have what sound it makes, and an animal can have names. These are all functions that you would define inside the class, right? Similarly, we have something called as associated functions and methods for that you can define for a struct. Now how will you implement? Now for animal has a as a thing called like what sound. Similarly, now you can define a similar function. Say user has this, and user can have another a function that you want to call, right? So first and foremost, you have something called as a constructor in oops programming, right? So how do I define a constructor? We use the impl keyword, impl keyword. It just directly means implementation. So implementation, impl user, right? Impl user, and then here I define the constructor. So you define the new method. So Rust emphasizes on using modern day design patterns. For those of you at least having a little bit of what design patterns are, you have multiple design patterns such as factory, builder, adapter, and all these patterns, right? Those of you who know, at least have heard the name design patterns or know a little bit of it, like just either say yes or something, or just celebrate, right? Yeah. So and who are beginners who do not know what design patterns are, as you once you learn a language, that is not the end to it. The way you architect your code, the way you imply write better code, and that is what matters as a programmer, right? So for that you will need to learn something called as design patterns. Every language will have most of the common design patterns, but like some systems level programming languages have additional patterns. And Rust I mean on its own emphasizes on factory, adapter, and the builder pattern, right? So I'll just, these are all the keywords. If you guys do not understand what I'm saying or it's gibberish to you, just make a note of all this and just make sure to either Google it, because I don't want to explain that, because it's not within the scope of our current boot camp, right? And moreover, that comes once you've learned the programming language, right? So new is the keyword thing I want to explain, and I use this fish symbol. So in Rust we call this fish symbol. People who write Rust code are called rustaceans. So rustaceans, among rustaceans, it's called the fish symbol. And with the new keyword, you declare the function, right? The new keyword will take the parameters that you want to use, what that you want to accept as a constructor. So similar to you write an animal class and you take the name of the animal or the sound that the animal makes, right? So same way you just define a constructor here. So say I say active. Active is of type bool, and username is string, and email is of type string, right? And now what I do, I need, so in Rust you need to always define your return type, right? So after the fish symbol, so the fish symbol is used to specify that you're going to return something in this function, right? So after the fish symbol, you need to define what is the type of person, or like what is the type that you're going to return. So here I'm going to return something called a self. I will get in detail about the self keyword, but a brief about it. Anytime you use the self keyword, it is a reference to the first instance, the owner of the instance. So even in class in Java, you might have used the self keyword, right? So that is, so self basically stands to the instance of that variable where it was instantiated with the new details, right? I want to return the self, and now I want to construct this entire thing here, right? And I just basically delete all this stuff. I don't need anything anymore. And do I need a colon in the end? No, you guys already know the answer, right? And so yeah, this is how a new method will be created, which means self is the original user, so it points to this user. So self here points to the struct user, right? I'm getting a new method which takes the attributes and then giving out the instantiated variable. So all I need to do now to get a new instance is let x is equal to user new, and I pass false, then whatever a, and then whatever email at b at, right? So I'll just, so yeah, so now if I try to print x, now it will still print for me. But this is the difference of how you implement functions on your struct. You use the impl keyword, you use the user, and this is basically how you define the constructor. This is as similar as what a constructor does in OOPS language, right? And these methods, are you guys going to tell me what is the error with all this, or is it fine? So firstly, the error is because it's of string type, right? So I need to just do string. Yeah, but the point here, what I want you guys to understand is, are you guys clear with how OOPS has some relation with a struct and a constructor? Is that clear? If that is clear, I want to proceed with the next.
Just a question, okay, sorry to interrupt you between. Like this impl function is to make a new constructor.
No, it's not just a new constructor. So in Rust, you can use impl multiple times. You can have multiple impl functions. So I'm coming to the next part. So your answer will get, you'll get your answer in the next section.
It's basically for implementing the new struct which we have used.
Not
right?
Just new, you can implement any number of functions. Now say animal has a sound function, now user has another function. I can implement say function get user, right? Or rename user. I want to rename my username, right? So you can implement the rename user function also inside the impl struct. And it's not only that, you can have n number of impl statements for a single struct. You can keep doing it.
Can we impl is like extending the functionality?
So impl just stands for implementation. That's it. You're just implementing functions or methods for your struct. That's it. That is the exact definition for it. It's just one simple word, implementation. So implementation of function for the struct.
No, not extending. You have to be clear of that. Extending means traits. Traits extend your functionality, but implementation is like creating new functionality for the specific type.
So to access rename user, we will use this access operator like 2 colons, right?
Yeah, to access rename. Yeah, we are getting to that point. Yeah, I will show the same thing. So yeah.
And by default, the constructor in Rust is defined by a new keyword. No?
Yeah.
New is used for constructor.
Yeah, so it's not like construct. It's just that OOPS has a constructor. You can assume new to be a constructor. Just for references, that's it. OOPS and the model here is different, but just for you guys to understand, I just told you guys. Cool.
Can you please explain a bit more about like the hashtag define and macro, because I was not able to understand like why you added hashtag debug and everything about the macros.
So yeah, like I said, your custom types do not have something called as like you cannot print those values because the compiler doesn't know what are the custom, like what is a custom struct about. It doesn't know what is the primitive value of a struct, right? So primitive values can be printed because the compiler knows it's a number or a float or a string or str basically, and all that, right? But when it comes to struct has attributes, and attributes are of primitive types, right? So basically it's not only that you need to implement debug for your struct to say that listen, this is a struct, and it implements the debug trait. And so when it implements the debug trait, I can basically at least print out the primitives that I'm using for my attributes. So that is how it is. So it's not, it used heavily in structs, the debug trait, the clone trait, the copy trait, and iterator trait. All this I'm coming up. Our next two topics are about traits and generics, but yeah, we'll cover that also. But does this answer your question?
Yeah, thanks.
Cool. So yeah, moving on. So yeah, let us what I want to show right now is a little bit of code on how structs work, right? So let us stick with the same thing. So I have a pub. So I don't need to define a struct at main scope. I can define it even outside of my main. So let us define pub struct as a person, and a person will have a name and say it is of type string, and I have age which is of type I32, right? And now what I want to build a constructor for it firstly, and say I want basically the new method. So to apply any number of functions, right? Person uh, person what I would do is pub function. The pub is basically a public. It just stands for the thing saying that this function can be called by another file in my folder, right? Pub function new, which basically has name, string, age, I32, and returns a self, right? Like I told you. So what happens in the new function? I return the self. So if I'm returning the self, I return person, which I declare with the name, which is equal to name. That's what I showed you guys in the other, age, which is equal to age, right? But you can also do this in a small syntactical sugar manner, which is basically you just don't need to say that this is the first parameter and this is second parameter, because Rust understands that if this variable is of the same type as my, I mean, same name of my attribute, you can just write it as it is. If it was a different thing, like say if it was X here, then I need to specify that age is X, right? So that's how it is, but you can use the shorthand syntax, right? So this is a new function. So now I have created this. So then like I said in my previous thing, I wanted to explain a little bit more in detail about the self keyword, right? So there are 4 ways that you can possibly try to use self, right? So the first kind of thing is you can have just self, you can have and self, you can have and mute self, and then you can have just mute self. Now what is the difference? Why are there so many selves, right? And I also said I had mentioned associated functions and methods, right? I literally use these 2 keywords, right? The first and foremost thing, whenever you are writing anything now say for example I want to implement a function, a person can greet, right? People can greet each other. Now say let's say I want to implement a function that says that greets 2 people, right? Now function greet, and so for this function I'm literally going to use the self keyword, so and a reference to myself, right? And the greet function is going to return a type called string, and here I use the format macro. Format macro basically is just for you to format your thing. Hi, my name is what is there by my self value, right? So self dot what is my name, right? So this is a read operation of self, and I'm just using the and self method, right? And similarly, now say I want to use person, and I want to write another function which says just something. So person wants to add the money that he has, right? X is I32, comma Y is equal to another I32, and it returns the fish symbol, and it returns another I32, and basically the operation is X plus Y, right? So the difference between these 2 things. So this is called a method. This is called associated functions, right? So what is, can anybody just looking at the code tell me what is the difference? First and foremost thing that you can see just looking at the code.
Like method is because of its referencing to the self.
Yeah.
And the other part is a function because it's just accepting the values.
Correct. So exactly. So whoever it was, good answer. So methods are, so you can immediately say it's a method, because if it has a self keyword in it and if it points to its own instance, then it's called a method. And associated functions are basically functions that accept various new parameters to do some sort of computation on the instance. So if I want to access add method, what I would basically do is here, now say I create a person, let x is equal to person dot new Alice, and her age is around 35, right? Cool. So now, so this is the way I instantiate my thing. Now if I want to use the add word, I would do x dot add and then have 1 plus 1 comma 2, and this is how I do it. And if I want to use the greet, you would use the double thing and greet with the message, right? So this is how you access variables. Now coming back to the point where I said there are 4 different types you can use. You can just use self, you can use a reference self, you can use a mutable reference to self, you can just have a mutable self instance, right? So the point here, what I want to say is self, firstly, self will own the value, will accept the entire ownership of that value when you pass it into a function, right? And self just gives you a reference to the self instance, and you're just doing read operations. You cannot mutate any and self variables, right? That is how it will be. And when it comes to mute self and mute self, what it means is it takes a reference and then it holds the mutable reference for this. So again, whenever you're writing such code, always remember that the first rule was you cannot have multiple mutable references. So if we have multiple functions, methods basically with and self, you can ask, okay, you're having multiple references to the mutable references, right? But that's not the case. Like I said, any reference will only live up to the function scope. But the moment the scope is end, it is reaches its last line of computation, it's over. You can still have it, right? So I will implement the iterator trait for you guys to understand what self is and how that is. Now or let's do this. Let's do this. So say I want to update the age of my person, right? Age up. And now I have used and self here, but now I want to update my variable, the instance of Alice here itself as x itself. I want x dot age to be a new value. I don't want to do that, right? So in that case, what I would do is self and mute self. So just look at the syntax, how it's written. It's and mute as one keyword, and then you have a space and then a self, and this will not return anything as a type that you're returning, because you're just mutating the original value, right? And now say I also want to take what is the new number, add age by what number, right? So I need, say we just take it as x32, and the operation I will need to do it is self. So I have the point mutable reference self dot age plus equal to. This syntax you guys must know, right? It's basically addition syntax, right? It's a syntax sugar for addition. And then I do n. So age will be added by this value. So now let's just see how that works now. So if I do x dot age up, and I give a value, say I don't know, 10. And now I want to print the value of just the age parameter of Alice, right? So I do x dot age. Now if you see, the value would have been increased by okay, there is just smaller. Then what else? And what else? Expected string greet format. So this is fine. Okay, I think that was the okay. X age of undeclared
create a module X.
where is X defined? So firstly, so if we have X here, so this is not how I call the function, it's dot notation. So associated methods are called by the dot notation, and functions are called by the age of this one. I mean the colon method. So yeah.
So all are basically associated functions whenever you use whenever you use IMP.
Colon. Yeah.
Yes. So
Correct.
associated functions are basically when you have a namespace of the type that is
Correct.
person.
Like how we
colon,
do it
colon.
with new. New is an associated function.
Right. So it's under the namespace of person. So
Correct.
while a method in which you have mentioned self or and self, whatever it is, you call it by the dot notation, which is x dot age.
Yeah. And if you see, I need to pass a mutable reference. So when I do x dot age up, it takes the self mutable reference, and you see the age is now 45. So I've declared it to 35, right? So this is basically what happens when you are trying to take the I mean work with and self and mute self, right? Similarly, you understand self consumes the original owner and mute also consumes the original owner, while these two are just references, right? That is what it is. Now say I write another function, say get age, right? Now pub function get age. Now get age will take a reference to okay, get age is another function on its own. So get age is outside of the impl syntax. Impl syntax ends at 28. Now say I implement another function explicitly that takes say s, and it takes a reference to my person, and it returns a referenced i32 value, which is the age value, right? And now I just return the s dot age, the reference of s dot age, right? Now the point that I want to tell you guys is that now say I have a mutable reference x, I have done the age up function here, and now I want to call the say let now so z is equal to get age, and which takes a reference to the person. It's not a mutable reference, right? So now if I just pass my x here and then print whatever this is, so you see there is a error that it's throwing. It says mismatch types. Firstly, it says expected and person, but the person here is the person thing. So firstly, I need to give a mutable a reference to it, right? So let's do that. Right. So now it is fine with me that it's just taking the reference and it's returning the variable as it is, correct? But if now if you look at now say after this I want to again do age up, right? Now say I just copy the same thing, and after a reference, so which this is a immutable reference. After an immutable reference, if I'm trying to do so this x age up anyway takes a mutable self reference. If there's an operation like this and I want to print the value of z right now, because the age will get increased again by 10, can you see this error? It says cannot borrow x as a mutable because it is already borrowed as an immutable. Can anybody explain this? Come on audio and explain it clearly.
Lokesh, we can't see you. Can you come a bit forward?
You're not able to see my screen, like
no, not the screen, but you.
Oh, okay. Cool.
That's okay. That's okay.
I think that's okay.
That's fine.
Yeah. So yeah, getting back, can anybody explain this? I've explained this again, but I wanted to show this error when you're working with structs and enums. But so yeah, anybody who had tried to understood the concepts that I told for the past say 20 minutes or half an hour or so can.
So actually, like you have to add ampersand mute So you have to give the mutable reference
At line number,
at line number 40.
please also. Okay. Do you think that will solve it?
I think so.
Okay. So I mean, it is not. It's a wrong answer, but I encourage whoever answered this. What is your name, sir? Yeah.
That's Tushar. I think in line 40, you are taking Z is equal to get age of X, where X is supposed to be mutable, but Z is not. So if you just write let mute Z is equal to.
Make Z as mutable. Okay. Can you please also tell me your name?
Chandra.
Chandra, I mean, very good answer. This is exactly the answer that I was looking for, and that's the thing. So, like I showed you in the rules, right? You cannot have two mutable references at the same time, right? That is what the rule is. So that is why this is throwing an error. So if I comment this, or if I try to do this after my Z command, and now I want to print my age again, this will work. The compiler let me work. So now do you guys follow how the rules of ownership and borrow is so important for you to understand when you're working with structs? Is this clear?
But at line 40, the scope ends.
At line?
After it is at line 40, the mutable reference, after it has evaluated,
no,
then the scope should end.
No, it won't end, because so here, so if you see the get age function, I am just taking a reference. I'm not doing anything with that, right? But the rule states that you cannot have two mutable references at a single instance, right? So you are taking one as an immutable value here, and immediately here, when I try to do it, I'm trying to again take a mutable reference to this, right? The rule says you can't do that. You can't do such an operation. Because if you see what I've defined for age up is a function that takes a mutable self, right? And similarly, age is a person that takes just the reference. It's an immutable reference, right? So I had explained this in the same variable concept. There's the same as variable, but just that we're using a struct. Is that clear? You just need to understand this little bit.
Okay, I'm sorry, but that at line 40, when ampersand X was being used,
yeah,
when it returns and then assigns to Z, then the scope should end.
No, because see, the scope doesn't end because my Z variable is not used after line 40. The difference of moving this to the lower line is that I'm utilizing Z here. The moment I've utilized Z, immutable reference at line number 40, the Z is out of my memory. It's no longer there. There is no longer an immutable reference to a mutable self of the same instance in the memory. That is why the compiler is letting me do this and self operation. Thanks. But if I move it up, what happens here is Z is still in memory with a reference that was not immutable.
Okay.
Is that clear?
Yeah, clear. Thanks.
Okay, got it. So are you guys able to relate to the ownership and borrow model with structs and enums so far? We'll just take a quick 3-minute break and we'll just go through whatever you guys want to know.
Yeah, I think Aditya is saying, can you explain it once again? Which part of it you want us to explain? Aditya, can you unmute yourself and ask? I got it. All right, good.
Okay. Okay, you are. So cool. And for those of you who still want explanation on this, I will just leave this link, the code link along with the explanation. So I have shared the entire, I've commented the entire explanation as, I mean, in descriptive words. So yeah, you can refer this and yeah, basically all of the code is here and also in the Rust book. So you guys can always refer to all of this. And if you see for every function, I would have left comments on basically what you guys need to understand, right? Cool. We'll just take a small 3-minute break to answer anything that they want, and we can move on to the next section.
Lokesh, can you can you once again tell me the difference between ampersand mute self and mute self?
Sorry, I kind of lost you a little bit.
Yeah, ampersand mute self versus mute self. What is the difference?
So ampersand self, like I said, ampersand self is a
no
reference.
ampersand that ampersand mute self, third one and fourth one.
Okay, third one and fourth one. So here this is a reference to my instance, but mute
Yes.
self will consume ownership.
Okay, consume ownership. Okay.
Yeah, it will consume the ownership. So yeah, it is not a reference. It will hold the actual value. It will take the actual value.
Thank you.
Yeah, sure. So like I said, for those of you who still don't know, so this is the link. So here, if you see, I have explained whatever I have told you guys about all the 4 types. You can refer this, and you can also see this part. I've written some comments. So
I think Julius has a question. Do you? Your voice is not audible for us. It's breaking in case if you're asking something.
okay.
Julius, are you asking something? If you could. Yeah, I think he went on mute. I think it accidental.
Okay, sure. So with this, I have like explain what basically structs are and what enums are. Enums are basically types that so I just don't want to get too much in detail of enums. You guys have already done the assignment, but I just want to explain it at least a little bit. So you see, like I say, enum is used by the enum keyword, and and you use the declaration here to define the members of your enum, right? So for example, you have an IP address which has either v4 or a v6 IP address type, right? And how do you access the members of an enum? This is how you do it, with the : syntax, right? And you can pass. So like I said, enum is a custom type that you are defining. So what happens is function root is IP kind, IP address kind, right? This is the type of this parameter that function route is taking, right? So this is most to do with enums. It's a very simple concept, to be honest, and yeah, and this is how you use it in terms of anything. So even inside a struct, if I want a kind of type enum, I add the kind here, and you can prolong, like continue with the code, right? Any of you who have doubts with understanding this, you can always post it out. We will answer it. And yeah, but this is mostly to compare about enums. The next thing I want to just briefly give you guys is the match statement. So Tejas, can you just take this up? I'll just quickly view it.
Yeah, the match statement. I'll share my screen. Can you enable sharing, Arsha?
Oh yeah, can you try now? I think you were co-host, I thought. All right, you should be able to do it. Can you?
All right. Yeah. Just give me a sec. Yeah. Can you all see?
Yeah, I think your Zoom thing is distracting. Can you cancel that? Yeah, we can see it now.
Can you see? Okay. Yes. So we're talking about match statements, right? So match statements are basically have 2 parts. So one is your patterns, and the other thing is your code. So for example, we mostly use match statements for pattern matching, as it mentions. So the first thing that we are going to do is to create enums. So let's say I'll create an enum of IP ADDR kind. And the variants were v4 and v6. Sorry, v6. All right. Now, second thing, what I'm going to do is I'm going to define the main function. Now we need to call this type into our match statement, right? So let's define a variable. Let's say some variable equals match. Okay. So before this, I think the first thing that we need to do is to define a type of IP ADDR kind to a variable and then match it. Okay. So let's say some value equals IP kind Sys of 4. All right. So now what I'm going to do is I'm going to put some value inside my PDDR kind, and then okay, IP PDDR kind 4. Let's say println. This is version 4 IP PDDR kind P6. All right. This is version 6. All right. Some variable. Okay, now can you all tell me what is going to be the answer here? I'm sorry, I can't see the chat. All right. Okay. So okay. So I want to point out something. We had previously told that we use some kind of trait to print custom types to the console, right? So I haven't done that. Can you tell me what am I missing, or how, or what should I put on enum so that I will be able to print it to the console?
Has include debug.
Yes. So this basically means I'm deriving the debug trait on enum since it is like struct. So you need to first implement the debug trait on the enum type, which is IP ADDR kind, so that you can print it to the console. Now, all right, let's run this. All right. So
some variable SOM while printing.
Some all right.
You need to use debug trait in println.
Cannot be formatted with a default format. Okay, okay. So there is one more error. Can somebody tell me what is the issue?
Display is not by default not implemented for this enum, so we need to use debug for that, right? So
Awesome.
it is formatting. Yeah.
Yes. Okay. So this is version 4, like someone pointed out. But there is one thing here. I am also getting this unit tuple. Can anybody tell me what is the issue?
Because you are not returning anything for the match, so by default it is like
right. It's because you are printing it twice. I don't want to print it twice. Since I'm printing it twice, it's giving me the unit tuple. All right. So basically, match statements are mostly used with enumerations for matching specific variants. So the things that you see inside the enum type is V4 and V6. They are called variants, and they can themselves have different data types. For example, if I do, let's say U8, 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 and U8, and V6 also, you can have like U32. So you can have enumerations with different data types as well. And if you want to access those, let's say the DDR kind, if I take B, C, and D, let's take it as A. All right. Now, let's take it this one. So I have to define. So, okay, so this is called instantiating an enumeration or instantiating a type. Okay, so whenever you want an instance of enumeration or a structure, you have to instantiate. Instantiate meaning creating a new type. So if I mention, since V4 has or V4 supports 4 different types or 4 different sections for the same type, I have to mention all of them. Let's say if I 1, 2, 3, 4. What do you all think? Will this work? Yeah, you can point on this.
So yeah, you guys can.
All right, I'll run it. Okay, now that you see, I was able to access all the values inside my variants as well. How? So like I told you, match statements are made of 2 things. One is the pattern and the other one is your code. So this arrow function or this arrow operator separates your patterns from your code. So this is your pattern. So A, B, C, and D represent 1, 2, 3, and 4. So from A, B, C, and D, I was able to access the first element or print the first element. You can print all elements if you want, but you can try that on your own. What if we change the println to format? Will it print just once? And no. So format is basically used for returning own strings. So basically you can have a return type as well rather than printing. So let's try format out. Format also exactly works like println, but ideally it's used for returning things. So format. Now let's say match arms have incompatible types found as string. What is the issue? Match arms have.
I think at the format level we are returning the string, right?
Right.
Dot to a string can solve it, I guess.
But there is no. Is that the problem?
All right. Can you explain what is the issue?
A dot to a string.
A dot to string. Okay. So just go through the error and try to like tell me what's wrong with this.
Can I try?
Sure.
Of course.
In what I have seen, if it matches V4, we are giving out a string. If it matches V6, we are giving out a string. If it doesn't matches either, it's empty. So it was printing those brackets. So
Okay.
basically we have 2 types. One is string and other is empty. So for string type, it has a given variable, but for empty type, it's giving out some other variable. I think that's the issue.
For empty type, it's giving out the other variable, but I am mentioning A as a return value, right? So basically println is printing to the console, right? But
yes,
here I am returning the string. So what can be the issue?
For V6 and V4, for V6, we are returning a string. For V6, we are not returning anything. It's just empty brackets.
Okay.
For one
So,
same match type. Yes.
So what you're suggesting, should I make this format?
Yes, and there's one more thing over here. We are just checking for V4 and V6. What if it's neither of those 2?
Neither of those 2. Okay, so firstly you have to mention what kind you want out of the enumeration. So you can't do that. So for example, if you're searching, let's say other than outside your enumeration, it won't work. So your match statements have to be exhaustive. Exhaustive meaning it has to cover all your variants inside your enum type. Is that clear?
Okay.
All right. So let's say if you mention V8 here as well, hypothetically, you have to mention the IP ADDR kind ::V8 as well. So let's try this out.
No, but he's asking the same thing. I'm thinking like if it doesn't match to anything, then what is returned?
So So the thing is, see, enums are types that have defined family members. So it's not like a struct variant or something that is not defined. So there is another thing also you can use. You can use the dead symbol to define anything. If it is anything else, you can match with others, right? That is also there. But enums, like whenever you define at compile time, the compile knows that these are the only family members for the enum. So it is not required for you to handle it. However, when you're coding normally, there is another syntax that you will need to use. So there you can just write down, right, that the dead syntax. So yeah.
So something like
nice.
this, let's say, if
Yeah.
I don't want to access other elements, what I will do is, I'll just mention something like this.
Exactly. So yeah. So we are not worried about who the other family members of the enum are or anything else. So we use this I mean, yeah, you can either call it the dead syntax or the underscore pattern. Basically, it's a placeholder. So you use the syntax to define that I don't care what the other things are. So if they are there, you do this operation or you do whatever you want. This is the answer to the question.
You got it. Now, since I mentioned that enums or match statements have to be exhaustive, you can bypass it by just calling an underscore, and you'll be able to make it. You'll be able to access the enumeration with only those variants.
Oh, yeah, got it. Actually, we are running match operation on an object. So this object must match one of its enumeration, right?
Yes.
Okay.
Yes.
Thanks. One more thing, I was like format and println, they can be running in only debug. Can that be running in live server and somewhere like
live? Okay, so basically, debug means when you're trying to know what your type holds and stuff like that, right? And so mostly you use the debug trait for knowing what your type currently holds, but you don't use that in production. You use your normal statements. That's it. Is it clear?
Okay. Yeah. Thanks.
A snake case basically is snake case is basically your variable having or word separated by an underscore. Yes. So is this clear?
Yeah, you guys can just say yes or.
Yeah, I think it's clear. Many of them are saying yes.
Cool.
All right. Cool. So what is the next section, Mahesh?
So next, we'll just explain options and result to them quickly.
All right. So option and result. Enum option. Okay, so can anybody tell me what option is and what are these? Right. So option is basically an enumeration that has two different variants called sum t and none t. Sum t and none. So if you compare it with IP ADTR find, you can see that sum is like v4. It is holding some value, but none is like v10. So basically option is used when you want your variable to be optional. For example, let's remove this out. Let's say some optional value is equal to I'll annotate as well, option of 32 10. Some optional value. All right. Now, can you all tell me what will this print out? No. So basically, this is just a way how it is defined in your standard library. I just wanted to point that thing out. So there are many things that are already present in the prelude. So what does prelude mean? Prelude means that there are some functionalities already available for you without you mentioning the standard library or anything like that. For example, let's say if you're mentioning use std fmt and let's say debug. So this means that you're bringing the debug trait or the display trait into scope of your program. So what does prelude mean? You don't need this. Okay, debug is already present there for you inside the program. Is it required debug? Yeah, it's actually derive is already mentioned on the option type inside the prelude. So we don't have to specifically define it. So can you tell me what this is going to print out?
Right now it will print error.
Okay, let's see.
We don't have the option enum
All right.
actually.
All right. Okay. So sum 10. Okay. So why sum 10? So basically, there is a concept called null in many programming languages, but Rust doesn't support it. So specifically to tackle this issue of null, this option trait or option type has been created. So I'll tell you the difference between none and null. None means there is literally nothing, zilch. Okay. Null, on the other hand, means an unknown value. It can be present or is not present. All right. So just to tackle that issue of null, which the other programming languages have, this is a much better way of handling missing data. So all right. Now if I make this none, it will still work. All right, because it is handling or it is expecting an option type. Is the option enum clear?
Nope, it's not. So like option is some sort of keyword over there, or it's
No.
just like they're making it for the sake to get the value in null.
No, none doesn't have any value. Okay, none means there is no value present inside this variable at the moment. That's what none means. So this is basically annotation. You can even remove this. All right, so it says cannot infer type of value t. Okay, that makes sense because Rust doesn't know at the moment what t means. So you have to mention what t means, which is I32 at the moment. So like I showed you that option t, t takes a value of I32 so that you can print it out to the console. But at the moment, since you're passing none, it will only print none to the console. It's like return -1. Yes, -1 is basically when you have an error. So it's not exactly like that. I'll come to relating to returning -1. So what's the practical use? So basically, this is like writing good code. Like handling null pointers is literally, you're going into an area where you're not knowing the value at some point, right? So that's why null pointers are totally avoided in every programming language. So we can use where we expect null values. Yeah. So
just a question. Sorry to interrupt. Like,
sure.
How is option defined over here? I'm not getting that.
Option defined. Are you talking about the annotation part?
Yeah. How is that option defined over here? Because we haven't made it as a separate enum or something like that.
Right. So that's why I was talking about the prelude. Prelude means some things are already in scope of your program. So for example, let's say if this is your file, option is already available for me. So that I don't have to write something like this. Okay. Let's say T and whatever. I don't have to specify an enum. So option is already available for me to use. That's why I can write option directly without creating an enum. Let's try this out also. No issues. Some T, sorry. Some T. Expected enum option found enum. Okay. Can you all tell me what this issue is?
The derived debug.
No, not exactly. So basically, this is my custom option. Okay, I have defined it in this file specifically, but what it's finding is from the standard library. So that's what I was telling you about the preload, right? So the option that you're seeing is coming from the standard library. This is an option that I have defined within the file. So it doesn't know which option am I referring to. So if I remove this, now it will know that the option that is coming is from the standard library. Standard library means a specific set of code that you have, which you can use. That is.
Okay, thank you so much. Got it.
All right. So everybody clear with option? There is one more enumeration which is very important, and which is called result. I'll proceed to that up. If you have any doubts, you can tell me. Is it clear? All right. So like option, you have okay. All right. So this is another enumeration called result. This is exactly like option in terms of availability. So this is also available for you in the preload, so that you don't have to specifically call, like you don't have to specifically make a result. Okay. Now I'll tell you what this means. Now these are like generic type parameters. So we'll come to that in the later section. But what these two variants mean is that a result holds two values or two variants. Either it can be a pass or it can be a fail. So pass can have a certain data type, and fail can also have a certain data type. So T represents that data type and E represents the error data type. So everything has a data type. So if you compare it with this, OK and V4 V6 are the same, and ERR and V6 are the same. Right? Now we mostly use.
Sorry to interrupt. Can you switch to dark mode, please? I think it's a issue.
Dark mode. I think it's UI theme is GitHub. Sorry, can anyone tell me where is dark mode here?
No,
So yeah, Rust Playground doesn't have dark mode.
That's okay. Continue to.
All right.
Sorry, Noor. Yeah.
Okay. So all right. Let's say if I mention an I32 and an I32. Let's not make this optional. Can you all tell me, will this work? All right. Why not? Okay. Okay. So you said no, right? Can you tell me why did this work?
Because it's defined in the standard library, like option.
True. But I have mentioned this okay one, right?
May I try?
But I am expecting here two types. It still works, correct?
I think since we have V6, it only asks for one type U32. Once passed that pass type of V6 U32, so that okay, I think it went to V6.
No. This is completely different. So ignore this. So this is a completely different program. Okay.
Okay.
So I'm not using enumeration IPADF. So this statement is a different entity. What I'm trying to ask is that I have mentioned that result I32 and I32 are present, but still I'm only passing one value.
So I think this result is for ignoring certain errors. Am I correct in Rust?
It's actually it's basically to handle errors. So basically you can have two values, right? So one is the correct value, one is the error value. So you can handle the error value, but when you get the okay value, it's all good, correct? So it's either this or this. So if I do okay one and I still run, I get okay one, correct? I can even mention, let's say ERR1. Will this work?
Yes.
Let's see. Cool. You're getting the difference, right? Both are variants that hold certain types, but their meaning is different. All right. ERR will also have some type that you will have to handle. All right. All right. So what is the other thing, Lokesh? Can we proceed?
So Tejas, I think we can conclude today's session.
Yeah, I think
and before concluding, I have a few things that I want to tell all of you. So yeah.
Should I stop sharing, Lokesh?
Yeah, I can start sharing. So I hope all of you have firstly like at least understood the basics that we have taught like today. I think we've gone through it like in good depth, like it's like almost every letter code wise. So I hope everybody been able to pick it up. Is that a yes, no, maybe, not really? Cool. Yeah, I think that's good. That's good to hear. And with the interest of time, so there are a few more topics to cover. So one starts with generics and traits, uh, which so I want to cover it in detail. But the thing is, I have already done this in one of our old bootcamp sessions, and I have been there's an entire 2-hour video on this. So this just covers your traits and advanced traits in Rust. And like, trust me, this is a very important topic that you guys really need to start understanding and go through. So this video is about 2 hours long, and each and everything in this is really important. And the code for this is already there in the GitHub link that I showed to you, and also the explanation. Like I said, I have commented everything, and you can also refer the book. And I want all of you to refer this video for the next topic, that is traits and advanced traits. Is that okay for all of you guys? So I have shared the link. So yeah, and the GitHub link, like I said, so I'll just give you an overview of so the next topic is about traits, and this one, which like I said, is in the video. I have explained each and everything like point to point in detail. So if you guys run into like errors or questions that you have, please post them on the Discord channel, and we will attend to it. And so the other thing that I wanted to cover is, so the code is, like I said, here you see mod 3 has basically trains, advanced states, your iterators, your generic types, your operators, and everything that you can see. And I have the code here. The same piece of code is also, along with the explanation, is also there in your Rust programming language, right? If you come here and you start working from generic types and trace behavior, I've also covered sections from chapter 15 and everything in the video, but all of that code is here. I want you guys to go through it, understand in detail. And yeah, so the explanation part, for if you guys want to prefer on a video, that is what I've done it basically. So yeah, you can refer to this. The code base is here. And moving on, there is another topic that I wanted to cover, was a little bit of how is functional programming operated on Rust, right? So for that, I have a little bit of examples that you guys can refer. So if you see, come to module 9 here, I have given examples of functional programming, basically the iter, map, flatten, filter, collect method, and the iterator, adapter, and all that. And yesterday, for those who were in the session, I had asked you guys to go through this iter, into iter, and iter mute. So these are all functional programming concepts in Rust, and these are something, these are basic fundamentals that you should know. And this repo has a lot of code examples. You guys can look at it. But so this is about the functional concepts. So if you see functional loops, right, we no longer use something like a for loop or something like that. So there's a question here. So this is the question. I have solved this with the example. So if you see it, I'm not using for loop, I'm not using any normal loop. So I'm doing iter, I'm using for each, I'm doing reverse, I'm using fold, I'm using a vector. So the same question can be solved even with a for loop. But these are the functional aspects of Rust that I wanted to show you guys, right? So you can always like have doubts, like write more code on this and get that. So this is mostly what I want you to guys to do in terms of Rust. So watch the video, understand traits and advanced traits in detail, and the functional aspects of Rust, and the generic aspects of Rust. So generics, we can, if you guys want, we can also do it a little bit of brief in the next session. Maybe take out half an hour from the current session topic, and if you want, we can just handle some doubts. But I want you to go through the video and understand it in detail before you come up with doubts, right? And the next thing is, with respect to what we have covered so far, what you guys can cover actually. So in the practice.rs, so it was lovely to see so many submissions. Harsha, I believe we had 80 plus submissions, right? Or Tejas,
So we
so
have more than that, okay. So before we move to the assignment, so we have created the Q&A link. Please register yourself to the Q&A so that you get the reminder to attend that session as well. Kavya, can you share the link? So I'm sure you guys gonna watch this video. There'll be a lot of questions for you guys.
Yeah.
So just give us a moment. Kavya, you there? Yeah, please register yourself. So we're gonna send you an email where you can fill the form and then ask the questions. So we will keep we'll be ready for that call. All right, okay, over to you.
Yeah, and yeah, coming here, so you must have been wondering, why am I giving you things to do when there's already a solution that you can refer? Like I said, it's not about trying to just copy code from Stack Overflow or any of the sites. It's all about you trying to understand what each line of code means, right? So which is why I write a lot of comments for you guys, right? So that is basically what I want you guys to do. So in terms of that, if you see, at the moment there should be enough of content or knowledge for you guys to at least attempt until 18. Functional programming might be it's not too hard, it's fine. So if you guys don't attend this also, it's fine, and there's no interesting. And again, about lifetimes, I'm not going to ask you guys to cover this at all. Chapter 17 is a skip, right? You don't need to do chapter 17 at all. And apart from that, formatted, println, these things we've already covered. Debug, display, formatting in detail. Comments and documents is fine. Crates and modules, these are something that you can go through. Result and panic, we just covered the result type and all that. Type conversions, I've just shown you how you can do it. And in terms of vector and hash map, I've shown you the string type, I've shown you the vector type. Hash map is very simple, like how you declare basically a vector you can just call standard collections hash map and start using. It's basically a key value pair, right? So a lot of use cases for these things come in even in our substrate, where we will be going using maps, storage maps in detail. Like it'll be a lot of storage maps that we use, right? I can stress this here, but I want to stress it more when we're doing it on substrate. So these things are pretty much basic, right? And generics and traits, this part you guys should be able to cover this once. So this is chapter 10. So chapter 10, when you've covered this entire video, right? So with that, now you have enough of knowledge to attempt. So 9 we have completed so far until 8. So you can start off with 9 methods and associated functions. I've explained it to you. Then 10 with the video. Collection types, it's simple. 11 I've explained. Vector, string, hash map is pretty simple. And type conversion, result, panic, it's done. Create module system, this is the cargo new. So this is it's do it on your own kind of thing, but we will explain the folder structure for substrate, and the folder structure for Rust project is very simple. It's just cargo new, it's either a lib.rs or main.rs, right? And yeah, so except 17 up to 18 you guys right now are should be able to do that, and you have about 2 weeks of time, right, to come across all this. And so so this is about Rust. So Tejas will give you more info about what blockchain concepts that you will need to do for the next before coming next session. But I just want to take any questions so far for Rust doubts. Anything, please come on audio or leave a message in the chat. I'll just respond quickly.
So let's close another 5 to 7 minutes. I think some mentors have a hard stop. So in case you have any questions, please do ask it. What is the submission deadline for this?
Yeah, 2 weeks.
We will announce this on the Discord channel.
Okay, yeah, we'll probably do that. Yeah, and yeah, so this is about Rust and things. Tejas, do you want to give them the substrate part of things?
Yes.
The blockchain aspects of things? Yeah, sure. I'll stop there.
So can you see the screen?
Yes.
Yeah. So basically what we want is, you all to do is go through the substrate documentation. I'll paste this in chat.
So this is the installation documentation of how you can set up your environment for substrate, right?
Yes.
So at least come prepared for this so that you can install this stuff.
Yes, and we also want you all to go through the blockchain basics, which is present inside the substrate docs only. I'll give you this link as well. So you have a ton of blockchain basics like why substrate architecture, networks and blockchains, runtime development consensus. So you'll learn a lot about blockchain and its basics. So learn about transactions and block basics. So it's a reading material that you can go through and understand the nitty-gritty about the blockchain development, which is required for substrate. So if you have a good understanding about all these things, so it's going to be really easy for you to get on with substrate and start hacking altogether. So the thing that we want you all to do in substrate, which is very basic, is to start a substrate node. So I'll give you that link first. Okay, so this is the link for building a local blockchain. So the thing we want you all to do is to clone the repo, go inside the node template and just build it. All right, so get this substrate node up and running. So this is like the first thing that you'll be doing for starting a substrate node. So we expect you to complete this part as well. And also,
you don't need to understand the code base or anything, right? Like we will do that for you, but at least we want you to set up the environment, install the tools, get the node running, understand the folder structure, try to look at lib.rs of every palette or the folders and try to figure out is the code at least getting familiar to you. If not, all the concepts that I've told, those are the ones that are required. If not, what are the topics you need to go back and work on, right? So those are the kind of things. We are not stressing you on understanding the subject code base, but at least have a look at it. Have a look at what it is.
Right.
So we'll share the same steps on Discord also, what all needs to be covered for assignments. I think that'll be much useful for you guys.
Yeah, anything like Remix or Truffle here or Substrate?
So we do have a Substrate playground, which you can use. You can definitely use that as well. So it is there in the substrate.dev link itself, accessing playground. But when you want to do your projects, when we give out your projects, we don't know if would it really help for you guys like to use it on a playground, because playground Substrate is a heavy code base. Yeah, you can either use your local environment or the playground as however it suits for you guys.
Okay, and anything like Ganache?
No, so there is a difference between writing smart contracts and writing a substrate based chain. So we will get into it for you, but Substrate basically it's a framework that lets you build blockchains, custom blockchains, right? It's a blockchain on a whole. You're starting a node on your own at your local thing. So there's no like frameworks like Ganache and stuff, but the chain will automatically start when you start your Substrate node template.
Okay, thanks.
Yeah, so installing Rust on Windows is pretty simple. I think last time I have shared a link on how to do it on Windows. So just refer that, Julius. It's fine. It's simple for Rust, at least Rust.
All right, I think we can have a small session on installing Rust. So whosoever is not able to install, just post your questions on, or just share the screenshot on a Discord channel. We'll be able to address this. I think that should help. Fahad Saif, could you please unmute and ask the question? Raise your hand.
Yeah, thanks for that. Yeah, just conscious of your time. One last question regarding Substrate. So we create a Substrate node. Let's say we run it on our local machine. I've just been reading about it before the class. Can we push this on any test network like we have in Ethereum? We've got Ropsten and Ringme and all that stuff. So I was reading Kusama. Can we like create a chain and push it somewhere, or a smart contract? I couldn't link that concept. So maybe a one-liner would help, but I'm sure you'd go in detail later. But otherwise, all good.
Yeah, I'll give you a brief right now. So you can, like you have test networks, Substrate provides something called as Kusama. Kusama is a test network for Substrate-based blockchains, right? Where you can basically host your applications. If you see, these are all the test networks that you have. You have Westend and Parachains, and each chain is called a Parachain in Polkadot ecosystem. You have the Westend network, you have the Roku network, and you have the Kusama as the main thing. So before your app goes into the main Polkadot chain, your parachain, which is your application, your D app, for example, will need to be run on Kusama chain to see if it's working fine or not. So this is a test network. But other than that, whenever you're running local, you can always link to your local node using this URL or any of the local nodes that are running. For example, these are our live nodes that we are running at Power Labs. So if I try to switch to any of these, you'll find a node running similar to this. So yeah, you can work it on local. And if you want to create your own test network and of sorts, like how some of the networks have, like for example, if you see test networks, there are Arjuna testnet, Zelf Zero testnet. These are their own blockchains that are running. So there is a kind of team, and they'll see what your application is on, and they'll approve it, and then you can create a testnet, and then it'll be shown. That is the process of getting a test network live onto the main UI experience here. But yeah, these are all the live networks that these are all blockchains. For example, if you guys must have heard ChainX or Polkadex. Polkadex is an Indian product, and the NFT Mart. All these things are basically blockchains built on Substrate framework, and they have their own network, and it's live. You can use all of these applications, right? So you can also look at Polkadot.js apps where you can look at all that. So is that clear? Does that answer the question?
Yeah, thanks so much for the great explanation. Yeah, that helps clear the confusion. Thanks.
Sure. So people who want to have a little bit of video demo can also.
Sorry. Lokesh, quick question. So this is all about test network and all that. Whatever be the code we develop, So is there any unit testing for this? Any framework we
Yes,
use to
yes.
test that?
So we have Cargo test. So Cargo has its own testing framework. You write test cases for unit testing, integration tests, and everything. Similarly, even Substrate, you have a lot of test cases that you can refer, write and all that. There is a huge test thing that we have to do. So if you want, I can show you an example of how we have written our test cases. So this is our project. This is our in-house hackathon submission project called Dot Marketplace. There's a video demo of this. I'll leave a link to this as well in the chat if you guys want to have a look at what one of the simple projects that we had initially built for one of the hackathons on Substrate, right? The entire team here, and you can read about all this. There's a video demo as well here. And similarly, in terms of code, GitHub. So this is our open source project, which is why I'm letting you guys refer the documents and everything. So if you see our the repository for the open source project, Dot Marketplace is the name of the project, and we come to our phase 2 branch. This is a project fully written on Substrate, and it has our own blockchain running. So for each palette that we have written, right, there is something called as test.rs. You have mock.rs. Mock is basically mocking your runtime, like the same way of mock testing, right? And mock.rs, you basically mock all your files that you want, and you build all the things that you want. And test is basically the file where we write all the test cases with the hashtag. This is an attribute macro where you write all the test cases here. So is that clear? Like someone who wanted to know about tests. So if you see, there's a in detail line of tests that we write. There are about 800 lines of code. Yeah. And we highly encourage a test-driven approach. So TDD is the behavior we do. So we write tests first and then get the functionality. So that is the right now industry level, production level. That is what is expected of any application, to have test cases first without the functionalities written. So yeah, anything else?
So we have the last question. I think Julian, this will be the last question. I'm sorry, we are running out of time. Julian, can you please go for it?
Yeah, I'm just wondering if you could recommend other things that people could be reading or using to practice if we're finding this difficult.
So I want to know the topics that you would want to cover.
I mean, at this point, let's just say everything, anything. Okay,
so let me stick to say blockchain and Rust. Is that fine?
Yeah, I mean, sure. Not so much blockchain. How about just Rust? Any ways that we could like kind of get more background knowledge, another source of material to help us, you know.
Got it. So so the thing about Rust is Rust is of like a language type that you need to write a lot of code. And the best way, to be honest, I know multiple languages. I have worked on it closely on the Java stack. I've worked on C++. I've worked on I'm not a Python developer, but I have worked on Python. Similarly, I've worked on Dart as a programming language. So yeah, I do know a lot of programming languages, and documentation for all these programming languages is not really very clear when I'm trying to learn. I need to go and access tutorials and stuff. But Rust has a very good book which is open source, and this book so I understand it might get hard reading stuff. So yeah, that part is there, but this book explains everything in detail. So if you cover at least up to chapter 10, you're like good enough to get into like intermediate level Rust code. That is, when I say intermediate level, you can start writing your projects, whatever you want to do, some command line programs, some web servers and all that. And the next one, that is why I asked you guys to use practice of RS a lot. So this is a very good thing, because you can try to, you have a solution even if you're stuck, and you can always look at the solution and try to understand how this piece works, right? That is for line by line code. Other than that, you have a lot of tutorials. So one such thing I would say is you can follow Let's Get Rusty, right? So let's get Rusty is a brilliant Rust developer, and if you come to his playlist, you will find that he's run through the Rust lang book completely. There are 44 videos throughout an year, so you can refer this as if you want like a video guide. So this is brilliant. There are a lot of projects as well. I myself have completed the whole thing. So yeah, so this is one brilliant tutorial that you can refer in terms of video series, and then there are few videos that even we have recorded sessions on the blockchain. But yeah, and mostly the repos is what I would ask you to focus. Like for example, I have this daily dose of Rust. Tejas has his thing, and there are a lot of developers in the Rust ecosystem have built very well project code bases. Like there are people I mean, whenever I find some, I'll just leave it in the Discord. But there are a lot of people who have written some good projects on Rust that you can write. So all you need to do about learning systems code is like try to understand each piece of word or the line that is written in the code. So that is how you would start off with Rust. And if you are more into reading, I can give you more books, but or other tutorials. But and into blockchain, again, we have books. So yeah, Ivan, is that what you want, or like anything more?
Yeah, I mean, just things to read, or kind of like easier practice projects to begin with.
Got it. So yeah, so I think this within this 44 videos, there are a couple of projects, or I think there are more than 5 projects that you do. So that will, and there is explanation for everything in that. So that will help you a lot. And second, if you just finish practice.rs, it is you're ready to understand the code of Rust. And apart from these, as a project level, I would explore all of you, not just Evan, to explore Rocket. Rocket.rs. So Rocket.rs is a web framework to write web APIs using Rust. There is another thing called Actix. Actix is my favorite, even Tejas' favorite. But the reason why I'm telling you about Rocket is just it's more beginner friendly. Unlike Actix, there is a little bit of learning curve that goes into it. But Rocket.rs is simple and very beginner friendly, and most of your code in Rust is pretty much basic. So those who guys who want to do some more projects on web APIs on this, so refer this. And in this repo, you have something called as examples, right? So in examples, he has a list of folders for every single thing that he wants to teach you guys. So this is another brilliant GitHub repo that you can always look at for what you want to do on Rocket. Rocket is one set example. And even in your Rust book, there are projects, for example, building a command line project. This is chapter 12 in your Rust book. And in chapter 2, most of you guys would have covered the guessing game. And similarly, you have IO projects, and there are a few more projects even here. But yeah, so OOPS concept, I've given you a brief of how OOPS are in Rust. So yeah, this is on. So here also building a multi-threaded web server. You don't really need to understand the multi-thread part of it, but even at least the first part, how using a single-threaded web server, it's similar to Rocket. Rocket works on a single thread. This will be a great thing. So I mean, for projects, you can start off with these things: command line applications, web servers, like this using Rocket framework. So is that good? So yeah, that is with Rust. And similarly, you have blockchain, and you guys can download this book for understanding basics of blockchain if you guys are into reading. Yeah. I mean, is that all right? Okay. Yeah, he said chat. Yeah, cool.
Yeah, sure. So we will share all these resources. Seth will share it in resources channel on the Discord. So please be a part of Discord in case if you're not. All right, guys, I think we have come to the end. So we extend 30 minutes more. So like I said, initially we are launching many offline events, the tech events and the hackathons also. For that, we need a lot of ambassadors help, right? So Polkadot India is launching ambassador program. So we will share the link in case if you guys are interested, please fill the form. So we will get in touch with you, and then we can coordinate. So it'll be a tech events for sure, and the hackathons also. So please be a part of our initiatives. We will, in case if you want to launch in your city, we will definitely seek help for you. So please fill the form carefully, so we will take it forward. All right, have a great weekend. We will see you guys in the next session. So next session is on is by the guest developer, the senior developer from Polkadot. Please don't miss. It'll be a lot of value addition for you guys. So we will share the link again in case if you guys are interested. All right then. Have a great weekend. See you guys next week.
Thank you all for attending.
Thank you. Adios.
Yeah.